Yeah, good afternoon to Gagan Sai. Yeah, today is the 7th class mathematics. Chapter number is the first integers. Today we will learn the new topic. And Telangana State Book page number is the 11. Today we will learn the 1.1.4 division of integers. Today we will learn it only. Okay, today is a new topic. Yeah, other book expert book part 2. Their other book after order take the another class one. Yeah, first of all today we will learn the Telangana State Book. Division of integers. Or you understood of the previous class Gagan said neatly? Exercise 1.4 all problems and solutions. Okay na? Multiplication of integers. Are you understood? The previous class is it's over and today we will learn the new topic in your 7th standard, division of integers only. Yeah, division means is the inverse operation of multiplication. Inverse operation of the multiplication. Let us observe that some examples only. Okay na? Some examples today we will learn it only. First of all is the some examples. Let us take your explaining on our notebook only. Division is the inverse operation of multiplication. Examples is that let us take, you know that Gagan side multiplication 2 cross 5 is the 10. Okay na? Yeah. Each multiplication statement there are two corresponding division statements only. Okay na? Each this is the multiplication only. Another example is the 6 cross 3. That is also 6 cross 3. You know that already are tables. Do you know the tables Gagan side? 6 cross 3 means is the 18 only. So that's why the each multiplication and it's the corresponding division statements for okay na, and there are the two corresponding division statements only. Yeah, first and second only. So that is the 10 is divided by 5 and 10 is divided by 2 only. So that's why 10 is divided by 5 means is the 10 is divided by 5 2 is 10. So that's why the coefficient is the 2 only. Next is the another one is the 10 is divided by 2 only. So that's why the 2 5 is a 10 0 only. So that's why is the 5 coefficient is the 5 only. Yeah, next is the another example is the this multiplication. This multiplication is a there are the two corresponding division statements only. So that's why is the 18 is divided by 3 equal to, and another statement is the 18 is divided by 6 equal to, yeah, 18 divided by 3 means is the 18 and 6 3 6 the 18. So that's why is the coefficient this is the coefficient and this is the remainder only. So that's why is the coefficient is the 6 only, and 18 divisible by 6 only. So that's why is the 6 3 is 18. So that's why the coefficient is the 3 only. Are you okay Gagan sai? Yeah, so from the example, so thus we can say that for each statement of a natural numbers, these all is the natural numbers. Do you know the natural numbers Gagan sai? 1 2 3 4 counting numbers, all are the natural numbers only. So that's why the each multiplication statement of natural numbers there are two corresponding division statement only. The another one is also you can also write a multiplication statements its corresponding division statements for integers also. Okay na? For integers, so I can write a multiplication statement and its corresponding division statements for integers. For let us examples the these are all the multiplication statements only. Division statements. Yeah, first one is that for integers. First of all are that division multiplication statement and division statements for integers. 3 cross bracket of -5. So that's why 3 5 is 15 -15. Okay Gagan sai? Yeah, next one is the division system. Multiplication statement is a corresponding two statement. Division multiplication statement. This is the two division corresponding the two division statements only. So first one the 3 cross bracket of minus 5 equal to the minus 15 only. So that's why our two corresponding division statement is the one is minus 15 bracket of minus 15 divided by the minus 5 only. So that's why coefficient is the 3. We will get the coefficient is the 3 only. So another division statement minus 15 by 3 only. Yeah, we will get that as a minus 5. Okay, 15 by 3. So that's why is the 5 only, minus 5. Next one is the multiplication statement minus 6 bracket of minus 6 multiplication of 5 only. So that's why is the 6 5 the minus 30. Now we will write the two division statements only. So first one is the minus 30 divisible by second multiplication, and we will get the coefficient is the minus 6 only. Another statement is the minus 30 divisible by minus 6 only. That's why we get the positive answer. The 30 divisible by 6 only. So that's why is the 5 only. Are you okay, Gagan sir, neatly? Yeah, next one is the another multiplication statement is the bracket of minus 8 multiplication of minus 9 only. So that's why the 8 9 the 72 only. Minus into minus is the plus only. So that's why is the 72 only. Yeah, we write the division statement. First division statement is the 72 divisible by minus 9. We will get the coefficient is the minus 8. Minus 8. And another one is the 72 is divisible by minus 8 only. We will get the coefficient is the minus 9. Are you okay, Gagan sir, neatly? From the above table of examples you can understand, Gagan sir. First we have got when we divide a negative integers, first negative integer is divisible by the positive integers. We get the answer is the negative only. Okay na? Positive integers is divisible by the negative integers. We get the negative integers only. Next is the negative integers is divisible by the negative integers. We get the positive integer only. Okay na? Positive integers divisible by positive integers. We get the positive quotient only. When we divide a negative integer by a negative integer, we get a positive number as the quotient only. Plus positive integers divisible by positive integers, we get the positive quotient only. And next one is the negative integer is divisible by negative integer. We get the positive quotient only. Next one is the positive integers is divisible by negative. We get the negative quotient only. And negative integer is divisible by positive. We get a minus negative quotient only. Are you understood the negative integer as the quotient? Negative integer, these are all is that a very important Gagan side. Are you are from the above table, you can from the above the examples, we got this all are that points only. Okay, now are you understood Gagan side? And next point is that some are other examples is also there. Bracket minus 81 divisible by 9 only. So that's why the answer is we will get the answer is the and a negative integer. Negative integer divisible with the positive integer. So that's why is the answer. So that's why the 9 9 the 81 minus 9 is the this one only. And next one is the second bit only. Yeah, here it is the bracket of minus 32 is divisible by 2 only. So that's why is the what's the answer here? It is the minus only, or minus is divisible by the plus. So that's why is the minus only. So that's why is the 1 and 16 only. 16 is the answer. So we can say that when we divide a negative integer by a negative integer, we get a positive number as the quotient only. Here it is that here it is that both are that Gagan side. Here it is the two examples only. Negative integers is divisible by the negative integers. Solution, you can write down the solution only. Yeah, negative integers is divisible by the negative integers. We get that the positive integer, positive quotient only. So that's why what's the solution here? It is a minus 36 divisible by minus 4. So that's why it's minus divisible by minus equal to the positive. First one is the positive quotient. 4 9 ja 36. And another is the solution is the another problem solution. Minus 201 is divisible by minus 3 only. So that's why the first one here it is the solution is here is the 201 3 only. So that's why the 3 6 the 18. So that's why the 2 only 1 3 7 ja 21. So that's why is the 67 only. Minus is divisible by the minus. It becomes to the plus quotient only. Okay. So that's why is the 67. Yeah. Are you okay? Divided by the negative integer is divided by the negative integer. We will get the positive integer of quotient only. Are you okay? Yeah. It's over of this topic. It's over. And next one goes to the another topic is the properties of integers only. What's the 1.2? Our page number is the 13. Today we learn it only. All the properties of whole numbers properties we already learned in the previous class only. So that's why we will learn that properties of integers also. Whole number it's over in our 6th grade. So that's why today we will learn the integers only. Yeah, first one is the properties of integers under addition and properties of integers under subtraction, properties of integers under multiplication, properties of integers under what's one is the division also. Yeah, these all is today we learn it only one by one only. Yeah, first one is the properties of integers under addition only. So that's why the first property is the closure properties. First one is the closure property. Yeah, observe the following the some statements only, some addition of the statements, and what's the conclusion? We get the conclusion of this one only. Yeah, first of all, these are the examples table form. Today we learn it only. Yeah, first statement 6 plus 3. What was 6 plus 3? Do you know that already? Know that addition of the two integers that can say? Do you know that? Yes. Yeah, what's one is 6 plus 3? 9. 6 plus 3 is the 9. Very good. So that's why the sum is also. The sum is. Is it a whole number? Do you know the whole number? What's a whole number? Whole number means is that 0 is also including. By including the 0 to for all collection of all are the natural numbers. So that's why the whole number. This is also 9 is also whole number. So that's why the 13 plus 5. 13 plus 5 is the 18. 18 is also the sum is a whole number. Is it a whole number? Yes. 10 plus 2 is also 12. Very good. This is also sum is the whole number. And 2 plus 6 is also 8. The sum is also. Is it a whole number or wrong? This is also sum is also whole number. So that's why the sum of whole numbers is always a whole number. Yes. Sum of these all is the two whole numbers. Sum is also whole number. Is it correct? This is a true or false? Yes, true. Yes, true. So that's why I say that the whole number. This is the closure property of addition only. Next one is the do integers satisfy a closure property of addition only. Integers also. We can some other examples of the integers only. So that's why the statement and what's the we will get the conclusion. What's the conclusion only? Yeah, first statement minus 10 plus 2. So that's why the what's the minus 8. So what's one is the minus sign is the bigger only. So that's why we get the answer is also you write it the answer is the minus sign only. So that's why the minus 8 only. Minus 3 plus 0. So what's the answer is the minus 3. And here some these are is the some examples that can say. So some examples of the statements only. Next one is the integers. This is the integers only. Satisfy the do integers satisfy the closure property of addition only. If you say check it only. Next one is the minus 5 plus 6 is the 1 only. And next with the 7 plus bracket of minus 6 only. So that's why the 7 minus 6 is it is the answer. If you get the answer is the plus what one is the integer only. So that's why the worst one is the here it is the 1 by 1 can say here the sum is an integer. minus 10 plus 2. Integer means is that what's the integer? Negative signs plus whole numbers. So that's why the here it is also all are the negative numbers plus whole number. We get the negative only. What's the sum is also is an integer? Yes, sum is also is an integer. Are you okay, Gagan Sai?
Yes.
Minus 8. Minus 8 means is the integer or whole number? Integer. So that's why the sum is all is an integer. Is it correct?
Yes.
Yeah. Next one is the minus 3. Your answer is the minus 3. Minus 3 is the sum is that is also integer. And another third example is also is sum is an integer only. And fourth also we get the sum is an integer. All in cases the sum is also integer only. Are you okay, Gagan Sai? So is the sum of two integer is always integer? Sum of two integer is always integers? Yes. All are integers only. Sum of two integers is always integers only. We get the always integer. So what's one is the? Yeah, therefore integers is also closed under addition. Okay, now?
Yes.
Here is it satisfied? Yeah, all are that sum of two integers is also. So integers is also integers. Integers are also closed under addition.
Okay.
Under addition. Are you okay, Gagan Sai?
Yes.
Integer two sum of the two integers equal to sum is also integer only. Integers is also closed satisfy anamata, that is also closed under addition only. In general, for any two integers a and b, two integers a plus b also integers only. So next property is the commutative property. Are you okay, Gagan Sai? Next is the commutative property. This is also, let us examples only. Let us following the some statement. Let us take the some examples only. Statement 1 and statement 2. We get the conclusion only. Are you okay, Gagan Sai?
Yes.
Yeah. Next is that these are that statement 1 and statement 2. What's the conclusion? Write it only on our notebook. Your first statement 1. Your commutative property. 4 plus 3 equal to 7. And 3 plus 4 equal to 7. Yeah, okay, Gagan Sai? Yeah, 4 plus 3 and 3 plus 7. Both are that equal. Is it the sum is also equal? And 4 plus 3, interchange of that 3 plus 4. Both are that sum is also, we get the same answer only. That is also 7 only. All are the cases. And statement 1 or another example, 3 plus 5. 3 plus 5 means is the 8 only. So 5 plus 3 is also 8. Here both cases are both are the equal. 3 plus 5 equal to 5 plus 3. We will get the same answer only in our both statements. So that's why conclusion is both conclusion is that same answer only. So that's why this is also. And next one is the goes to the another example, 3 plus 1. So that's why is the 4 only. Yeah, 1 plus 3 is also 4. Statement 2 answer is also both statement 1 and statement 2. Both answer is the same. So that's why the both are that equal only. 3 plus 1 equal to 1 plus 3. Or we will get the same answer is the 4 only. Are you understood, Gagan Sai? Yeah, what are you are observing? Yeah, pair of that whole numbers only. 2 pair of the whole numbers is the sum is also whole number only. Okay, na? Is it correct, Gagan Sai?
Yes.
If you are interchanging of that whole numbers is also sum of the whole numbers, interchanging of sum of the whole numbers is also the same answer only. Are you okay? Both in our both are cases, if it's both are the same answer, we will get the same answer. So that's why you can the addition of the whole numbers is the commutative. Okay, na? Commutative property. Satisfy. And next one is the second one is the is addition of the integers commutative. Yeah, that is also take the some examples. So statement 1 and statement 2, or we get that the conclusion. And one by one is the whole numbers if we check it, and other next is the integers only. Yeah, this is the integer part only. The statement 1 is the 5 plus integer means is the minus negative numbers is also there, negative. So that's why is the next 5 plus bracket of minus 6. We got the answer is that minus 5 minus 6. So that's why is the minus 1 only. So that's why is the statement 2. Interchanging of the two integers only. Yeah, minus 6 plus 5. So that's why we get that the minus is the bigger only. So that's why that big sign is we write the answer is the big sign only. So that's why icon is the minus 1 only. We get the answer is the both are that both answers is the, is it correct? Minus 1 or minus 1, both in case it is both answers is that same answer only. So that's why the both are that equal only. And both statements 1 and statement 2 is equal. We get the answer, same answer only. And next is the example of minus 9 plus 2. So we get the answer is the minus 7 only. So that's why I can statement 2. I ulta I can ulta. So that's why I can 2 plus minus 9. We get that the same answer. Both are the, is it correct, Gagan Sai? Both cases is it the same answer? Negative?
Yes.
Integer? Is it correct?
Yes.
So that's why both are that equal only. What's one is the minus 9 plus 2 equal to 2 plus minus 9. We get the same answer, that is the minus 7 only. Another example is the minus 4. Minus 4 plus minus 5 only. So that's why I can, what's one is the minus 4 plus into minus is the minus only. So that's why the minus. So that's why the minus. What's one is the 9 only. Is it okay, Gagan Sai? Yeah, next is the another statement 2. So we write this like only minus 5 unchanged only. Yeah, so that's why the minus 4. So that's why this in this case statement is also our same answer. We get the same answer. So conclusion is also both are that equal only. So what's one is the first one is that minus 5. Other statement is also our same. That is also we write it only. That is also our both, we will get that the same answer, that is also minus 9. Also you can observing here it is from the above examples all are the can observing here it is that pair of any two integers. Sum is the different, is it the different or same? Same, but here both are the interchange. If you interchanging of is also same only. And if you satisfy this one only, and what's what you can understand, addition is a commutative for integers is also satisfied. Okay, now are you understood, Gagan Sai, neatly? Therefore, addition is commutative for integers. Whole numbers is also it's okay, and next is the integers also. Its addition is satisfied. And next one is the general for any two integers a and b. A plus b equal to b plus a. Okay, now. Any two integers and 5 plus minus bracket of minus 6. Two integers only. A plus b. Sum is means is the minus 1. So that's why equal to b plus a. This also sum b plus a. Interchange of this one only. So that is also same. We get the same answer. So that's why both are the equal only. This is the general form of the integers only. Okay, now next is the another property is the associative property. What's the associative property? Let us take the some examples of the associative property. Yeah, first one only. First examples you can solution, you can write down the solution. I can say first one is the, first of all I read in our example only. And take bracket of 2 plus 5 plus 4. Okay, now another is the 2 plus bracket of 5 plus 4 only. So that's why the 2 plus 5 means is the 7. 7 plus 4. Is the next one is that what's one here is the 2. 2 plus bracket sum is the what's the sum 5 plus 4 is the 9 only. So that's why 7 plus 4 is the 11 and 2 plus 9 is also 11. Are you okay, Gagan Sai, neatly? You can all are that everything. Another examples are 3 examples here. It is Gagan Sai are one by one only. First one is the 2 plus 0. 2 plus 0 means is the 2 only. Bracket of 2 plus 0 plus 4 equal to the 2 plus 4. Another you write it that another one only. What's for this is the 2 plus 0 plus 4. So that's why the what's one is the 2 plus 0 plus 4 means is the 4 only. What's the 2 plus 4 means is the 6, and here it is also 2 plus 4 means is the 6 only. Next one is the 2 ways you can write it this like only. Okay na?
Yes.
Yeah, 2 plus 3. What's one is the 2 plus 3 means is the 5. 5 plus 4. And here it is the another way also write it on 2 plus 3 plus 4 only. So that's why is the 2 plus 4 means is the bracket of 3 plus 4 means is the 7 only. Okay, Gagan Sai? Yeah, next is this like only. And next is the 5 plus 4 means is the 9. This is also here it is the 9 only. If it's or you understood Gagan Sai, 3 problems it's over. Sum of the each case are equal. Each case of the sum is equal. All are the answers. Yes, all are that equal only. So that's why this is that satisfy a true or false. True. Is it a true only? All are the cases it satisfy only. So that's why what's our here it is. Therefore, integers follow the associative property under addition. Okay. Therefore, integers follow the associative property under addition. Okay, now in your both are the sum is it equal? Your this sum and this sum.
Yes.
Both are the equal only. So that's why the integers is follows the associative property. General go for any three integers A, B and C. So that's why here it is the 3 integers only. 1, 2 and 3. A, B, C. Okay now. A plus B plus C equal to A plus B plus C. Okay, here it is given neatly A, B, C only. For examples of A, B, C. So that's why A plus B plus C equal to A plus B plus C. Both are the easy to sum is equal. Yes, it is all both are that equal. Yes, it is equal only. So next one is the 2 ways you can write it this like only. Okay na?
Yes.
Yeah, 2 plus 3. What's one is the 2 plus 3 means is the 5 plus 4. And here it is the another way also write it on 2 plus 3 plus 4 only. So that's why is the 2 plus 4 means is the bracket of 3 plus 4 means is the 7 only. Okay, Gagan Sai? Yeah, next is this like only. And next is the 5 plus 4 means is the 9. This is also here it is the 9 only. If it's or you understood Gagan Sai, 3 problems it's over. Sum of the each case are equal. Each case of the sum is equal. All are the answers. Yes, all are that equal only. So that's why this is that satisfy a true or false. True. Is it a true only? All are the cases it satisfy only. So that's why what's our here it is. Therefore, integers follow the associative property under addition. Okay. Therefore, integers follow the associative property under addition. Okay, now in your both are the sum is it equal? Your this sum and this sum.
Yes.
Both are the equal only. So that's why the integers is follows the associative property. General go for any three integers A, B and C. So that's why here it is the 3 integers only. 1, 2 and 3. A, B, C. Okay now. A plus B plus C equal to A plus B plus C. Okay, here it is given neatly A, B, C only. For examples of A, B, C. So that's why a plus b plus c equal to a plus b plus c. Both are the easy to sum is equal. Yes, these are both are that equal. Yes, is equal only. So next one is the additive identity. Additive identity is also observing the following some additions of the examples only. Your words are there. These all are the some examples. So solutions, you can write down the solutions neatly. Yeah, first one is the minus 3 plus 0. Minus 3 plus 0 means is the integer. Minus 3 plus 0. Here what is the, we will get the answer is the minus 3 only. And your second example is the 6 plus 0. 6 plus 0 means is the 6 only. Positive integers. And 0 plus 3. And 0 plus anything is the same number only. We will get the same number only. So that's why you can, what sir, you can is the 0 is the an integer. Yeah, 0, adding up the 0 is the integers only. We will get the same answer. Same answer, we will get the same answer only. So that's why you can say what's on is the 0 is the additive identity. Okay na, additive identity for integers only. Okay na?
Yes.
0 is the additive identity. Additive identity for integers. Okay, is it okay, Gagan Sai? Are you clear?
Yes.
Yeah, anything you can add it, same answer we will get it only. In general, for any integers, a, and a plus 0 equal to 0 plus a equal to a. Okay na? You can observe here it is a plus 0 and your 0 plus a. We will get the same answer. Reverse answer is the a only, but here 0 is the nothing value. So that's why I can is the that is the, we will get that the same one. Here it is also textbook is also, try this also, all are that try is also so you can let after later you can all are that practice only. This is also a 2 plus 2 alag examples of try this is also there in our textbook. Sample, if you take that, it is all the example sample, you take it and you can practice everyone only. Okay na? Everything you can practice other examples also. And next one is the property of that other property is the additive inverse property. Yeah, additive inverse is also some examples of here it is also additive. The first of all your what should be added to, or here it is 3 to get the additive identity 0 only. What's one here, for examples of following here it is that 3 only. 3 ki we get the answer is the 0. What should be added? What should be added of this one only? Minus 3. Additive inverse. Additive inverse, do you know the additive inverse? Gagan say, for examples of a is the additive inverse is the minus a only. For examples of 2. 2 is the additive inverse is the minus 2 only. So that's why you can, what should be added of the additive inverse of, we will get the answer is the 0. What should be added? Here it is that minus same number you can add it of this one only. Additive inverse of the same of same only. So that's why you can always get the answer is also 0. For examples of 6 plus what should be added? Here it is also additive inverse of the same number, same integer. So that's why you can, that is also we get the answer is the 0. Alag examples, for examples of minus 10 plus here it is that plus 10. So that's why you get the answer is also same, and the additive inverse of that alag integers you can take it, you can rewrite it only. Other examples also after later you also practice only. And one integer is called as the additive inverse of the other integer. This is the one integer and plus other integer, additive inverse of the other integer. So you get the answer is the 0. Okay now, in general for any integers a, there exists an integers of minus a such that a plus minus bracket of minus a, additive inverse, we will get the answer is 0. Okay now, a and minus of a are additive inverse of each others only. Okay now, both are the each others only. We will get 0 and both are the cancel only. Here it is the plus 3 minus 3 cancel. Okay now, are you okay, Gagan Sai? Here is the properties of the under addition is also it's over. Whole numbers and integers is also it's over. And next topic is the 1.2.2 properties of integers under multiplication only. Next is the multiplication. Yeah, first one is the closure property. One by one, yeah, check it only. Closure property. Yeah, what integers under multiplication. First one is the closure property. See better neatly, listen better neatly. Look at the textbook neatly or notebook also. Here are some examples of the following, that some examples only, table formation. You can today we learn this one only, closure property. Okay, na some examples of statements, and we get the what's the conclusion. We can write it in our table form. Okay, na? Yeah, first one is the first statement. Or alag examples of this or the statement. Yeah, multiplication. Do you know the multiplication? 6 cross 8. 6 cross 8 means is the what's the table? Do you know the table?
Yes.
6 cross 8 is the 48. And 10 cross 0 is the 0. And minus 15 cross 2. Your alag multiplication statement is the minus 30 only. So that's why the minus 15 cross 3 is a minus 45. My class student, you can say, listen better neatly. Your words are here. It is that both are that integers only, whole numbers. So that's why the product is also integer. Okay, na? So that's why the product is also integer or whole number? Integers only. These are also integers only. So that's why is also, first one is the first one is that integer, and the second is also the product is also, yeah, this is also integers. The product is also integers, and this is also integers. So the product is also integers only. And some whole numbers and integers both are there. Some are this 0 is also, and this is also whole numbers also. Yeah, but these are the negative numbers is all are the integers only. So that's why this is also our minus alag examples so statements here write it only in our table form. First of all, yeah, what is the minus into minus is the plus only. So that's why is the plus. 11 into 8 is the 88, and 10 into 10 is the 100. And 5 cross minus 3, bracket of minus 3 is the minus 15 only. So that's why is all are the product. What's the product is also? Yeah, the product. Yeah, the product of whole number. This is the whole number or integers. So both are only. Whole numbers or integers as a whole number. And this is also product of whole number, and this is also product of integers. Okay, Gagan Sai? Integer only. Yeah, are you understood, Gagan Sai, neatly? Is the product of any two whole numbers. Is the product of the any two whole numbers. The product is also integer or whole number only. This is a whole number. Okay, Gagan Sai? Product of the any two, what's one is the whole numbers, the product is also whole number only. The product of the any two integers, the product is also an integer only. Okay, Gagan Sai, neatly understood?
Yes.
Product of the any two whole numbers, always a whole number? Yes, always a whole number. The product of any two integers is always a integers? Yes. Is it correct?
Yes.
Yeah, therefore integers follows the closure property of addition. Are you okay, Gagan Sai? Therefore integers follow the closure property. Property of multiplication. Is it okay, Gagan Sai? Are you understood this case? Multiplication. Are you understood? Each property, write it down. Here in general, if A and B only, A and B are two integers, and A cross B is also an integer. Yeah, the product of any whole numbers is also whole number. Yes, product of the any also you see better in our other example here. This is all are that integers only. Integers of all are that are in the table form of all are that some examples of the integers only. So that's why the product is also an integers only. Okay, na negative numbers means is the integers only. Or this is a whole number. Whole numbers means is some examples of here it is also there. 2 cross 3 means is the 6, 5 cross 4 is the 20, and 3 cross 6 is the 18. These all is the product is also is it the whole number or integers. Yeah, these all is also product is also whole number only. So that's why it is also 2. Is the product of any two whole numbers is always is a whole number? Yes, that is also always whole number only. Okay, now are you understood the concern neatly? Commutative property. Commutative property and multiplication is a commutative for whole numbers. We know that already. We know that the multiplication of the commutative for whole numbers. It is also our commutative integers. First here is statement by and table formation. Today we learn the some examples only. Today we learn it only. Statement 1 and statement 2 and we get the conclusion only. Yeah, these are the statement 1 and statement 2. We get the conclusion only. What's get the conclusion and today we learn it only one by one. Examples statement wise. We write in the table form. Today we learn it only. Yeah, first one is that 5 cross alag examples gagan say solutions is also 5 cross bracket of minus 2 equal to minus 10 only. So that's why statement 2 is a unchanged only and minus product is that unchanged. So that's why the minus 2 cross 5 we get the same answer. Both are them there. Statement 1 statement 2 we get the same answer. Yes, same answer only. So that's why both are that equal only. Both statements are equal. So that's why the 5 cross minus 2 equal to minus 2 into 5. We get the conclusion is also minus 10 only. Both are that equal only. You can write it the another examples also. First of all, minus the bracket of minus 3 into 6. What's the answer is the 3 cross 6 is the minus 18. So 6 cross minus 3 is also statement 2 is also same answer. We get the same answer. So that's why you can statement 1 and statement 2 both are the equal. So that's why you can 6 cross minus 3 same answer. We get the 18. And other examples is also 20 minus 20 into 10 only. So that's why the minus 200 only. So that's why the second statement is also 10 cross minus 20 bracket of minus 20. So that is also we get the same answer. So that's why the both statement is are equal. So that's why the 20 10 equal to 10 into bracket of minus 20. We get the same answer. That is also 200. Conclusion is also same. Are you understood the concept neatly? Yes, and all are the above cases. What's are you understood? Product of in two integers is an integer gagan side?
Yes.
Yeah, product is also integer only. Okay, na? So therefore, the multiplication of integers follows the commutative property.
Yes. Okay.
Therefore, multiplication of integers. These are all the multiplication of integers only. We get that conclusion is also same. So that's why I can is the words commutative multiplication of integers. So follows the commutative property. Are you okay, Gagan Sai?
Yeah.
Yeah, first of all, you write it in our box only. First, you are in general for any two integers a and b, and a cross b equal to b cross a. We get the same answer only. Okay, are you understood, Gagan Sai? A cross b equal to b cross a. We get the same answer. Is it both are that equal? Yes, answer is also equal. So that's why both statement is also equal one only. Yeah, this is also associated commutative property for integers is also satisfied. And the next one is another is the third one is the associative property. Associative property of some let us consider a multiplication of minus 5 and 2 and 3 only. These all are that group of statement. You can write it first of all one by one only. Yeah, first statement of this one is the minus 5 into 2 plus you write it group wise. So that's why icon is the 3 1. Here it is the 3 1. Okay. Yeah, next one is the another and minus 5 into 2 cross 3 only. Bracket close. Are you okay, Gagansa, neatly? These are is the one group and this is the another group only. First group and second group. This is the first group and this is the second group only. Are you both are that equal, or if it says solution, you can write it only one by one, step by step you can write it the solutions only. First of all is the minus 5 into 2 is the minus 10 only into from 3 only. So that's why this statement whatsoever it is the minus 5 into 2 cross 3 is the 6 only. So that's why the minus 10 into 3 is the minus 30 and minus 5 into 6 is the minus 30. Are both are that is it equal? Equal, Gagan sai? Both are that product is equal answer? Yes, equal answer only. Your first group of this one and second group of this one only. Both are you can together we get this same answer only. So that's why you can what's the answer is multiplication of integer is also associative. You can are you understood again neatly? Therefore only write it only one example only. Other examples is also there in your other examples. If you take your textbook is also there. Other examples also I explaining in our textbook. Gagan sai. For examples of 2 comma minus 3 minus 4. These all are that group wise you can write it that two statements only. Where this one and this one only. Yeah, first one is the 2 cross minus 3. Yeah, this is the one group. You write it product of the minus 4 only. And this is also 2 cross 3 cross 4. Minus what? Minus 3 cross minus 4 only. This is the second group only. Yeah, 2 cross minus 3 means the minus 6 into or minus 4. And our another one is the 2 cross minus into minus is the plus only. So that's why the 3 cross 4 is the 12. And your minus into minus is the plus. So that's why the 6 cross 4 is the 24. And your 12 cross 12, 2 cross 12 is also 24. In your first case and your first case of this is the product and this is the second case of the second group. Okay na? Here both are the product is the answer. We will get the product is also same answer in our both cases. Yeah, both is also the same answer only. So that's why you can both are the equal only. And this product is both are the equal only. So that's why therefore the multiplication of integers is a associative. Okay na Gagan sai? You write it the another step you write it Gagan sai and both product is also it's equal only. So that's why you can in this step cross 3 only. Okay na? Equal to minus 5 into we write this this one only. Yeah, both are that equal only. So that's why you can is the therefore the multiplication of integers is associative. Okay, Gagan sai? Yeah, that is a satisfy associative property. Associative, the multiplication of integers is associative. You write it the general. Which property wise you can write it the general for any integers. For any integers a comma b and c comma a cross b cross c equal to a cross b cross c only. Both are the product is equal. Are you okay, Gagan sir, neatly? See that neatly some here examples is a cross b equals c only. And here it is that a cross b cross c only. Both are that is it equal? A cross b into c. Here it is that a cross b cross c. Or both are that equal? Yes, both are that equal answer only. So that's why that is the minus 10, minus 30, minus 30 only. So that's why you can both are that equal only. Yeah, this next one goes to the other property, the distributive property. Distributive property or same other examples is also try. This is also so better, or it is also you can after lot you can practice these or is the some examples. Okay na? Yeah, at home only these or is the homework only. Okay. Yeah, next goes to the distributive property is a fourth one only. Yeah, first one is the distributive property. You know that already you write it only. You can this is the one example. You can say 8 cross 12 plus 2 equal to 8 cross 12. The multiplication and distribution over addition is true for whole numbers. These all is the whole numbers only. 8 cross 12 plus 8 cross 2 only. Okay, now distributive over addition is true for whole numbers only. So let us see, this is true for integers also. If it's whole numbers, it's over, and next one is to the distributed. Distributed means is a separately, right? Okay, now first product addition of the second product only. Write it that distribute only. So that's why I can is that this is also it's over of the whole numbers, and next one is the this is true for the integers. Integers if it's a satisfy or not another, if it's a one by one today we learn the other examples also if we take it only. Let us consider the another examples only. For examples of that other examples is that anyone can say 2 cross 1 plus 4 equal to bracket of minus 2 into 1 bracket close plus minus 2 into 4 only. Yeah, minus 2 into 1 plus 5 is the 5, 1 plus 4 is the 5 only. So that's why is the minus 2 into 2 it means 2 cross 1 is the minus 2 only. Your plus what's one is that here it is that minus 2 into 4 is the minus 8. Here it is the 2 cross 5, minus 2 cross 5 means the minus 10 only. So that's why the minus 2 plus into minus is the minus 6 only, minus 8 only. So the 2 4 is 8. So that's why it's the 8 only. Yeah, here is the minus 10 equal to minus into minus is the minus 10 only. So that's why can both are that equal. Yeah, is it equal only? Are you okay? Can say neatly or see but another examples is also there in our textbook is also I am explaining in our textbook only. Some are two examples here it is. Yeah, minus 1 into bracket of 3 plus bracket of minus 5 only. Here it is we write this like only. Separately you can write it that this one only. Yeah, minus 1 into 3 and plus of that next is the next product only. What's our next product is the minus 1 into bracket of minus 5 only. So that's why you can is the minus 1 3 plus 5 is the minus 2 only. Next equal to the minus 1 into 3 is the minus 3 plus minus into minus is the plus 1 into 5 is the 5. So that's why we get the answer minus into minus is the plus. So 2 plus 2 here it is also this side is also LHS RHS and here it is also but this is also minus 3 or that is also 2 only. Yeah, plus 2 plus sign is the big only. So that's why we write it the answer is also write it the plus only. So that's why we get that both are that in our both cases the answer is the same. Is it correct, Gagan?
Yes.
Yes, both are the equal answer.
Yes.
So that's why our other examples is also see better that is also our same answer. We get the both cases.
Yes.
Yeah, first and second. Yeah,
Yes.
write it this like only. Yeah, that is also our same only. So that's why you can is the left side and right side and both are the left and right side equal both are that we get the same answer only.
Okay.
LHS and RHS both are the same only. So that's why you can is the multiplication distributes over and addition of integers is also satisfied. Is also 2 only. Other examples are also can practice there. Can say textbook is also, but yeah, only are one example. So can write it here. It is only. So that is also it's over. And next one you can what's I can observing here it is. Are both cases are is it equal?
Yes.
So that's why you write this like minus 2 into 1 plus 4 equal to minus 2 into 1 plus bracket of minus 2 into 4. Okay na? So that's why the multiplication, therefore multiplication distributes over addition of integers. That's 2. Okay na? Yeah, next is the general. In general, for any integers, a, comma b and c. Yeah, general form for any integers a, comma b and c, a cross b plus c equal to a cross b plus a cross c only. Okay na? Here it is gagansa a. ఇది a cross b plus c equal to a cross b plus a cross c. Write this like only. అంటే a cross plus b plus c అంటే a b c only. So that's why can a cross b plus c equal to a cross b. Write the plus a cross c. Multiplicative identity. Yeah, these are the example of solutions. Okay, are you understood? Yes. Yeah, one by one. Yeah. Multiplying any integer by 1 only. Any integers is multiplied by 1. Does not change the integer. Change the integer. If it's integer is same only. Same you can 1 is and 1 multiplying by 1 means is the same answer only. We will get the same answer only. This one is called as the multiplicative identity for integer only. Are you okay, Gagan? Say neatly. Yeah, these are the multiplicative identity only. 1 is the. Are you understood, Gagan? Say neatly. Multiplying by the any integer only. Or 1 is multiplying by the any integers. We will get that the same answer only. So that's why is the 1 is the multiplicative identity only. So write it here. It is Gagan. Say neatly. Yeah, 1 is a multiplicative identity of integers. Okay na? Identity of integers. So write it in general for any integer a and a cross 1 equal to 1 cross a equal to a. Okay na? Okay. Yeah, both are that equal. And if any integers you can multiplied by the 1, we get that the 1 is a volta is also. Write it the volta is also same answer only. We get the same only. So that's why is that, or you understood the concern. One is the 6th one is the multiplication by 0 only. So that's why the multiplication by 0 is the sum is that you know that the whole numbers of when multiplied by 0 it gives the 0. Yeah. Yes. So that's why we know that only. So that's why is the what happens of in this case of the integers. I can observing the following only. Okay na?
Okay.
When you multiplied by the 0 gives is a 0 already or no. You already they know in our previous properties. So that's why is the what happens of in this case of the integers. Here these are what is the integers only. So that's why what are observing here. It is for examples of these are only solutions. You can write on the solutions. You can say minus 3 into 0 is the 0 and 0 into minus 8 is the -0. 0 is nothing but anything is multiplied by the anything so we get the 0 only. So that's why this is also 9 cross 0 is also 0 only. So that's why this shows that the product of an integer and 0 is 0. Okay na? Product of any integers, the product of any integers and 0, the product of the any integers and 0, we will get the answer is the 0. Okay, I can write it that in general. For any integers a cross 0 equal to 0 cross a equal to the 0. Are you okay, Gagan? Say, are you okay? Anything and if it's the product of the any integers and 0, we get the answer is 0 only. And if it's both are there a and A cross 0 equal to 0 cross A, 0 only. Are you understood the concern neatly? Yeah, today we learn the exercise 1.5 all problems and solutions. Our page number is the 19 only in Telangana State book. Our first bit only. First of all, I read it only. Verify the following. Here it is the two problems there. Yeah, first of all, first problem. 18 cross bracket of 7 plus minus 3 equal to 18 cross 7 bracket of 18 cross 7 plus bracket of 18 cross minus 3 only. So this is the LHS and this is the RHS. Equal before is the LHS and equal after is the RHS. So that's why you are verify it only. LHS equal to RHS, both are equal or not equal. If it's equal, it's true. Otherwise, you can false. Otherwise, you can not equal only. So that's why you can first of all you can solution. You can write down your notebook only. Yeah, verify the following. Yeah, first one only. This is the LHS and this is the RHS only. So that's why LHS means is the 18 cross 7 plus into minus is the minus only. So that's why the 7 minus 3 bracket of 7 minus 3. Here it is that. Next one is the 18 cross 7 only. So that's why 18 cross 7 means is the 7 8 ja 56. 7 1 ja 7. 7 plus 5 is the 126. Okay. 126 plus 18 cross minus 3. 18 cross minus 3 means is the 3 8 ja 24. 3 1 ja 3 plus 2. So that's why is the 5 only. Minus 54 bracket of minus 54. Next one is the 18 into 7 minus 3 is the 4 equal to 126 minus plus into minus is the minus. So that's why is the 54. 18 cross 4. 18 cross 4. 4 8 ja 32. 4 1 ja 4 plus 7. So the 72. Next 126 minus 54. 126 minus 54. So that's why 6 minus 4 is the 2 only. So next again is the 12 minus 5 is the 7. So that's why is the 72. Okay na? Yeah, this is the both are the LHS equal to RHS only. Both are the equal. So that's why it's a true only. 72 LHS is also 72 and RHS is also 72. So that's why you can both are the equal. It's true only. The statement is true. And next one is the second problem. First of all, I read it only in our textbook. Bracket of minus 21. Next into bracket of minus 4 plus minus 6 only equal to bracket of minus 21 into bracket of minus 4 only. Next plus bracket of minus 21 into bracket of minus 6 whole bracket only. Okay na? Yeah, this is that first of all solution you can write down in your notebook only. Yeah, this is the LHS and this is the RHS only. This is the LHS and this is the RHS. Yeah, first one minus 21 as it is you can write down. And next one is the bracket minus 4 plus into minus is the minus 6. Next one is the minus 21 into 4. 21 into 4. 4 1 ja 4 and 4 2 ja 8 only. So that's why the minus into minus is the plus 84. Next plus 21 into 6 only. 21 into 6. 6 1 ja 6, 6 2 ja 12. So that's why the minus into minus is the plus only. So the plus 126 only. Okay. Yeah. Next is the another step. Minus 21 into minus 10 only. Next minus 4 minus 6 is the minus 10 and then again is the 126 84. 6 plus 4 is the 10. 2 plus 8 is the 10. 10 plus 1 is the 11. 1 plus 1 is the 2 only. So that's why it's a 210. This one RHS is the 210 and this is also 210 only. Minus into minus is the plus. So that's why this is also 210 only. So yeah, both are the LHS equal to RHS. Both are equal only. But that's so statement is true only. Okay, Gagan, say neatly. Yeah, are you understood? Both are the equal only. Both sides are LHS and RHS. Next one is the about second bit only. The second bit is also are two problems there. First one only. First I read it only. For any integer a, what is bracket of minus 1 into a equal to question mark? What is this like on product? Product of equal. Words are equal అనేది. Both are minus 1 into a. What is equal to? Minus 1 into a means is the minus a. You already know very easy problem, that is that second bit of first one is the very easy only solution. Yeah, for any integers what is it? A means is the minus 1 into a equal to minus a. Very easy. Okay na? This is the first problem solution. And next is the second problem. Are you okay, Gagan, sir, neatly? Yeah, next one. Determine the integer whose product with bracket of minus 1 is 5. So that's where whose product, this like only. Minus 1 ki which product? Which product is multiplied by which one only? We will get this like 5 only. What's you can other integer, what's on it? Determine the other integer only. Okay, you can understand, Gagan, say. Determine the other integer. One integer is already given. What's the other product of integer? What's one here? It is that minus 1. Which one? Which one is the other one only? So that's why the other is the dash equal to we get the 5 only. So that's why other integer. What's the other integer? Here it is the minus already. One integer is the minus only. So other integer is also minus. Why? Because here it is that plus only, positive integer only. Here it is the positive integer. So answer is the positive integer. So that's why it's a minus into minus. This is the second integer is also compulsory. Must and should have the minus only. So that's why it's a minus 1 here it is. And again is that 1. 1 is multiplied by the 5. Equal to we get the minus into minus. We will get this same answer only. Otherwise is also let x only. What's one is the, you don't know that the other integer. So that's why is the let x only. So this is that other method is also. The second method is also this only. And what is that 5 by here it is that product. So that's why is the minus 1 only. Okay. Yeah, this is also it's over of 2 bits it's over, and next goes to the third one only. Yeah, next one is the bit only. Complete the following products using suitable properties only. First here it is the first to 8 problems there only. First problem. Yeah, first of all I read it only. 26 multiplication of bracket of minus 8 plus bracket of minus 48 into minus 36 only. Bracket of minus 36. So that's why I got this one. Gagan say solution you can solve in our notebook only. Yeah, first one is the 26 into multiplication of 48 only. 48 into 26 only. So that's why the 6 8 ja 48 only. 6 4 ja 24. 24 plus 6 4 ja 24. 24 plus is the 28 only. 2 8 ja 16. 2 4 ja 8. 8 plus 9 only. So that's why is the 8. 8 plus 6 is the 8 plus 6 means is the 14. Next is the 9 plus 1 is the 10. 10 plus 12. Yeah. This is the it's over, and next one is the minus 48 36 only. Multiply by 36. So that's why the 6 8 ja 48. 6 4 ja 24, 24 plus 4, 28 only. 3 8 ja 24, and then again 3 4 ja 12, 12 plus 2, 14, 8, 8 plus 4 is the 12 only. Next again is the 2 plus 4 is the 6, 6 plus 1 is the 7, 1728 only. So that's why this is that both are the minus only, plus into minus is the minus, so that's why the 1248 plus here it is that both are the minus into minus is the plus only, so that's why is the 1728 only. So that's why the both are the, we will get the answer is that what one is the 12, both are the subtracted are 0 and 12 minus 4, 12 minus 4 is the 8 only, so that's why is the 6 minus 2 is the 4, so that's what's the answer is the plus 480 is the answer is correct. Okay Gagan, are you understood? Therefore this one 480 is the answer. Okay, calculation is the multiplication is the very big number, so that's why it is the so it's take a time only, it's take a long time, so that's why this is the answer of 480 only, so that's why our second problem solution only. Yeah, first of all I read in our textbook only. 8 cross 53, cross of bracket of minus 125 only, so that's why solution in our notebook only. First of all 53 8 only, 8 3 ja 24 and 8 5 ja 40, 40 plus 2, 42 only, so that's why is 424 into minus of 125 only, so that's why both product Gagan sai are 424 125 only. Multiplication of this like only 5 4 ja 20, 5 2 ja 10, 10 plus 2, 12, 5 4 ja 20, 20 plus 1, 21 only, 2 4 ja 8, 2 2 ja 4, 2 4 ja 8 only. Yeah, 1 4 ja 4, 1 2 ja 2, 1 4 ja 4, so that's why is 0, 2 plus 8 is the 10 and 1 plus 4 is the 5, 5 plus 4 is the 9, 9 plus 1 is the 10 only. Next one is the 8 plus 2 is the 10, 10 12 13, 4 plus 1 is the 5 only, so that's why the 53,000 only, 53,000. Here it is the plus into minus is the minus only, this is the answer. Okay, yeah, it's are you understood Gagan neatly? Yeah, next goes to the third problem. Yeah, next one is that third problem. 15 cross bracket of minus 25 into bracket of minus 4 into minus 10 only, bracket of minus 10 only, so that's why I can first problem solution you can write down in solution only. 15 cross 25 and 25 multiplication of 15 only, so that's why you can is the 5 5 ja 25, 5 2 ja 10, 10 plus 12, 1 5 ja 5, 1 2 ja 2 only, so that's why is the 5, 2 plus 5 is the 7, 2 plus 1 is the 3 only, so that's why is the 375 minus of 375 into minus into minus is the plus, so that's why is the 4 into 10 is the 40. Okay na, into 375 multiplication of 40, here 0 0 0. So next again is the second one is the 4 only, so that's why is the 4 5 is 20, 28 plus 2, 28 plus 2 is the 30, 4 3 is 12, 12 plus 3 is the 15 only, so 0 0 0 5 1 only at 15,000, so that's why is the minus of 15,000. Okay, this is the answer. Are you understood Gagan neatly?
Yes.
Yeah, next one is the fourth problem only. Yeah, first of all bracket of minus 41 multiplied by 102 only. So that's why this one is 102 multiplication of 41. 102 into 41. So that's why the 1 2 ja 2, 1 0 0, 1 1 ja 1, 4 2 ja 8, 4 2 ja 8, 4 0 0, 4 1 ja 4, 2 8 1 4 only. So this is the answer, 4182 only. Okay, now here it is the minus order. Minus into plus is the minus. So that's why this is the answer. Are you understood Gagan neatly? Yeah, next one is the fifth problem. Yeah, first read it Gagan in our textbook. Yeah, 625 multiplied by my bracket of minus 35 plus bracket of minus 625 multiplied by 65 only. Cross of 65. Yeah, first one is the solution only. Yeah, 625. You can observing here it is the Gagan sai. Yeah, this product and this product, both products are there here. It is common out. Take what's the common is the 625 and here it is also 625. Both are the 625 is the common only. So you can be carefully observing here it is 625 is the common out. Remaining product you write it in our brackets only. What's our remaining integer only. So that's why this one is the remaining is the minus 35. Here it is that second product which one is the common? Common is the 625 and remaining is the minus 65 is the common other one only. Next 625 minus 35 minus 65. Minus 35 minus 65. So that's why is 5 5 ja 10. 6 3 ja 6 plus 3. 9 9 plus 1 is the 10 only. 100 minus 100. Okay, Gagan sai. Yeah, next one is the 625 into 100. So that's why is the first one is the 622,500 in the solution. Are you okay, Gagan sai neatly? Are you okay? Yeah, next one is the sixth problem. 7 multiplied by bracket of 50 minus 2 only. Bracket close also. Next solution. 7 cross 50 minus 2. 50 minus 2 means is the 48. Both product only. What's are both? One is the 7 cross 48. 48 7 ja 7 8 ja 56. 7 4 ja 28 only. 28 plus 5. 28 plus 5. 33. 336 answer. Okay, Gagan sai. Yeah, next one is the seventh problem. Yeah, bracket of minus 17 into bracket of minus 29 only. Minus into minus is the plus only. So that's why the product of this one only. Both product. Which one? This is that 29 into 17 only. So that's why the 7 9 ja 63 only. 7 2 ja 14. 7 14 plus 6 is the 20 only. 1 9 ja 9. 1 2 ja 2. 3 9 2 2 ja 4. Okay now. Is it correct, Gagan sai?
Yeah.
Minus into minus is the plus. So that's why the 493 is the solution. Okay now. Next is the last problem. 8th problem. Bracket of minus 57 is multiplied by the bracket of minus 19 plus 57 only. Yeah, it is that you can observing you can say minus into minus is the plus only. So that's why the 57 multiplied by 19. So that's why the 57 19. 9 7 ja 63. 9 5 ja 45. 45 plus 6. Yeah, 51 only. 1 7 ja 7. 1 5 ja 5 only. So that's why the 3 8 10 5 plus 5 is the 10 only. So that's why the what's the answer here? It is plus 83 1083 and plus 57. So yeah, this is the 1083 plus 57 only. So that's why the this one only. 7 plus 3 is the 0 and 8 plus 5 is the 13. 13 plus 1 is the 4 and 1 and then again is the 1 only. So that's why the what's the answer is the 1140 answer only. So that's why the today our exercise 1.5 all problems and solutions is over. Are you okay, Gagan Sai?
Yeah.
Yeah. Next one is today's class is also it's over. Say tomorrow onwards we will continue the next topic only. Say thank you. Have a nice day, my dear Gagan Sai. Say bye bye.